Assalamu alaikum. This is Sadia Bashar, and in this video, I will explain accumulator, B register, and output register of our simple as possible SAP 1 architecture based 6-bit computer design and implementation project on behalf of my team Error 404. So this is basically our whole design, and if we focus on the mentioned registers part, they all are 6-bit register and parallel in parallel out register. We all know the basic function of the registers is to store the data and give output after the finish of processing. Now if we go to the child sheet of accumulator, we can see that D flip-flop has been used, as D flip-flop is the easiest one to use out of all other flip-flops, and we were instructed to allocate 6-bit memory in the register. And here also buffer was used, tri-state buffer, to prevent the bus contention. Here positive triggered quad flip-flop was used, and we all know that one flip-flop stores 1 bit of memory. So we had to use 6 pins of the ICs, and AI and AO are the two control bits of accumulator, and also accumulator is also known as A register. Now if we go back to the parent sheet, and now similarly for B register, D flip-flop was used, and BI is the only one control bit of B register. And for output register, there are also only one control bit called OI, and D flip-flop was also used there. Here we can see one IC was commonly used for 3 of the registers, and also a buffer was used. The IC was 74AC173. It's a positive triggered quad flip-flop, and this is the pin diagram of that IC, and this is the pin diagram of the tri-state buffer IC. Now, if we focus a bit on how these registers are worked, accumulator and B register will receive data from the bus by these 6-bit lines, and they are also connected internally with ALU, and data will pass from accumulator to ALU and also B register to ALU, and arithmetic and logical performance will performed by ALU here. Also, to receive data from bus, for accumulator, AI is needed to be activated by controller sequencer. Also for B register, BI will get activated. And after the finishing of the performance by ALU will give the data to the bus, and from bus, accumulator will receive the data and store the data. And AI will be activated in this part of the cycle. Then the data will be stored in the A register, and also accumulator has the ability to output intermediate results after each ALU operation. And when the output unit is needed to display the result, output register will receive the data from A register via bus. Output register will receive the data, and a register will give us the data, and when OI got activated, output register will receive the data from bus, and they will show the data, show the final result here. Here we can see the final result, and this is how the registers are working. And that was all for the video. Thanks for your patience hearing. Assalamu alaikum.